Good afternoon, everyone. First of all, I would like to ask you a question. Please raise your hands or put some kind of reaction into the chat. Have you ever used QGIS? Are you a GIS software user? Have you ever used QGIS or ArcGIS? Okay, I see a lot of people. And now I would like to understand how many people have never used GIS, any GIS, like ArcGIS, QGIS, Online GIS, whatever. Like just to understand what is your level of familiarity with this type of software. Okay, because today I would like to show you one plugin for QGIS, and I will explain you what is QGIS for those who don't know, which will help you to use different Earth observation data sets and incorporate them into your GIS systems. Because I assume that like in your organizations you're working, you have maybe some custom national geoinformation system, or you're using some of the existing ones and just tailor them for your needs. But anyways, today's session is all about how to actually access and do something with Earth observation data, even if you don't usually work with it. It's just nice to understand to understand not just what Earth observation data can bring you as different projects and data sets, but actually how you can access them and use them, right? So I would like to start today's session with something very, very simple, something which doesn't require any installation of software on your desktop or any specific background knowledge. And it will be Copernicus browser, which I shown you in the end of the previous session. So I'm going to share my screen, and what you need to do, you need to Google Copernicus browser, and probably the very first link you'll find will be the link to the Copernicus browser, and you need to log in if you already have an account, or do a very quick registration, which is for free, to be able to try to do different things in it, right? Okay, so I'm sharing my screen, just a second. Here it is. Do you see my screen now? I think you see, yeah?
Yes, you can see the screen.
So this is Copernicus browser. It's free of charge. You just need to register to be able to use the full amount of functions and capabilities. What this web platform can help you to do. So first of all, you can simply visualize Earth observation data from different satellites, specifically from different sentinels, which are part of Copernicus mission. Also, you can create different visualizations, the ones we discussed during previous sessions, like different band combinations or different indices. Also, you can create like time lapses, download or build some statistical indicators, like a change of like soil moisture or plant moisture or amount of chlorophyll in plants and so on. And it's very basic tool, but what it can be useful for? It can be useful for preparing some presentations, checking very quickly different events and situations happening currently in your countries or areas of interest, and so on. So, and apart from just visualizing data, you also can download raw satellite data to use it further in different environments like GIS software, or if you're a more advanced user of things like this, you can use some R scripts or Python scripts to drive some data from this imagery you are downloading and so on. So let's start just from visualizing an image. I shown you how to do it in the end of the previous session, but we can try to do it again. So, for example, what we can try to do, we can try to look at some flood event, for example, which happened in Poland in 2024 in September, in a small town. Well, it was happening all around Eastern Europe, but in a small town called Klocko. To do so, you just need to enter the area of your interest here in the search field. and then you will see the list of locations, and you just select the one you actually want. To locate it more precisely, you just need to zoom in. Again, here it is. Here is Globscope. And according to the information I got from the internet, there was a flood event happening there somewhere around 15th of September 2024. So let's try to take a look at it using Sentinel-2 imagery, which is optical passive remote sensing. The satellite has a optical passive remote sensing sensor installed on it. So let's try to take a look. First of all, currently we are seeing the latest Sentinel-2 imagery obtained for this area, but we want to find the precise date, precise year. What we need to do for visualizing it, again, pay attention to what kind of data set we are looking at. So we discussed last time that there are different levels of data processing. There is like more raw data, which is not really analysis ready. And then there is a highest level of satellite data processing. It will have different name for different types of satellites, but for Sentinel-2, it's Sentinel level 2A. So now we are looking specifically at this data set. And now we need to find the specific date, yeah? And as we mentioned, it was in 2024. So we just need to use this panel to find it. It was in September, and it was happening somewhere around September 15. So there are, like you will see here, for which dates images are available. So it would be 6, 8, 18th, and so on. And depending on how many clouds are acceptable for you for this image, and again, to better understand what it's all about, this maximum cloud coverage setting, it's about how many percent of our scene or our satellite image will be covered with clouds. And of course, if it will be covered with clouds like 100%, we won't be able to see anything. So we just need to lower the threshold, and we will see images which are more suitable for us. And we see that, for example, 3rd, 6th, 8th of September highlighted more brightly, meaning that those images correspond to our threshold we just said, and others like 11, 13, 16, they have more cloud cover. Yeah, because a flood event was happening, so probably it was lots of rain, lots of cloud, and so on. But just for us to understand how we can search for satellite data and how we can visualize satellite data, which actually will help us to see anything. So let's visualize, for example, 18th of September. And here it is, this image. Currently, we see it in a band combination, which is called true color. So it's like red, green, and blue parts of electromagnetic spectrum. But we can visualize it also in like another band combinations, or we can calculate different indices, like for example, NDVI or a moisture index, which shows us how basically moist the Earth's surface. Or there are some others, for example, this band combination of near infrared, shortwave infrared bands very nicely highlights the state of vegetation or some wildfires and so on. Okay, so here it is. We have this image. Now what we can do with it? So let's imagine that we found something we wanted to see on this image. Here, and you like the visualization, you want to use it for some kind of report, for example, you can just download it. There are several downloading options available, more low resolution one. There are some more advanced options like analytical one, for example. You can download not just this visualization, but others or raw bands of a satellite image. You can select resolution. You can decide if you want it to be georeferenced or not. What it means that if you open it in any GIS software, it will be immediately located where it's supposed to be on a map. It won't be just an image. It will be immediately located on a place where it actually was taken, right? So after this, you can download it. Apart from this, what we can do, we can visualize different indices. For example, this index, which is showing us state of vegetation, we can build like a chart, statistic of how specifically in this area average NDVI values were changing within time. To do so, we just need to build a polygon and click this statistical info chart icon, and it will be built immediately. And then we just need to select for how long we want this to be built, and it will include all available imagery for this region into this chart. But of course, again, here the cloud threshold is 100%, and if we lower it, we will have less imagery because only imagery with less than 20% cloud coverage will be included, and we will get more precise data. And after doing so, you can just export this information as a CSV file, and you can also use it in different reports you are doing, and so on. But again, it's very it's very basic, but still kind of helpful tool for using Earth observation data. Apart from this, what we can do, we can download raw satellite imagery. For example, before this, I wanted to show you how to do more advanced things. So here we have a list of different visualizations which are available here. But let's imagine you want to do something more custom. You have some specific type of event or disturbance you would like to monitor, and you can create a custom script which will help you to do so. Even if you don't have any scripting background, you don't know any programming language, there are several scripts developed by different enthusiasts and published for free, which you can use inside this platform. How you can access those scripts or see the catalog of these scripts? You just need to Google Sentinel Copernicus browser custom scripts, like this, and you will see, for me it's a second link in the list of the results. It will be Sentinel Hub custom scripts, by it's called Sentinel Hub because before there was a Sentinel Hub platform which had the same functionality as Copernicus browser, but then let's say rebranding happened, and now it's called Copernicus browser, but scripts are the same. So you just need to open this website, and you will see here names of different satellites. And if you open unwrap the list, you will see, for example, that for Sentinel there are different Sentinel satellites available, and currently we're working with Sentinel-2. So let's go to Sentinel-2 section, and you'll see all different types of custom scripts available for visualization of different things. I see some questions in the chat. I will quickly take a look what's going there. Okay. No questions, basically. Okay, great. So now we see here different custom scripts, and let's imagine we want to visualize, for example, some like forest disturbance. We want to create a map of forest disturbance based on satellite imagery, or we want to create a map of burned area derived from Sentinel-2 or something like this. Let's select something interesting, something forest related, for example. All scripts are separated into different categories. So there would be like cloud detection algorithms, snow and glaciers algorithms, disaster management, land use, land cover classification, vegetation, agriculture and forestry, and so on. So let's go to agriculture and forestry. And we can see here that there is something which is called forest disturbance classification. So let's try to use this one. And when you open the page, you will see that there is a script which we need to copy, which we are going to use in Copernicus browser. It's our first step towards building something custom together. Here you will also find the script description, what it shows, how it was built, by whom, some examples of its use, and so on. If you don't have any specific area you want to look at, you can just open here one of the links, evaluate and visualize, and then it will show you some random example of use of this of the use of this script. For example, this one. And we can see that there are different types of forest disturbance which were detected using this algorithm. Just like this, very easy. You just open it and here you are. And here you can change the location or the date, or if you are more advanced user of programming languages, you can even change some parameters to adjust the script, like change the colors of visualization and so on. The legend of what this script is actually showing will be found on every specific page of every specific script. But if you want to use it for your specific location, you just need to copy it. Give me a second. You just need to copy it, go back to our location, and here in the end of the list of visualizations, you will see something which is called custom. And here you can create custom composite, a custom index, or a custom script. So there is a script already, which is basically something which creates the visualization we are currently seeing. But to use our own script or custom script from the library we just discovered, we just need to remove this one and insert our one, which we just copied, and just click apply. And it will happen. Now we just need to wait for a second till it's loading. And after it's finished, you can just download this image, and this will be it. While it's downloading, the question: is it possible to create a mosaic with custom scripts and then feed it into the Copernicus Jupyter notebook without using up virtual machine storage and then process it in a virtual machine notebook? Well, I will show you something which can be helpful a little bit further in today's webinar, because Copernicus data space ecosystem, it provides different capabilities. So this is like the basic one, and then you can also use Copernicus API, create your own visualization, access layers which are already there, and you don't need to use your virtual machine for this, because it will be processed in the Copernicus backend. And it's for free. They give you a specific amount of credits for free, and even if you used all of them, you can ask for more for free, which is very nice. Okay, so here it is, our script. Apart from this, also quite representative and nice for different reports, just to show people what's going on. There is such a nice function as a time lapse. Here it is. You just need to click this create time lapse animation icon, select area which you want to be included, then just select a time range of satellite imagery you want to be included. Again, cloud coverage, how many images per day, per week, or per month you want to be included. Click search. Click search. Then there will be all this imagery. you can deselect those images you don't like, keep those you actually do like, and then when it's done, you can see how it ended up looking, and if you like it, you can download it. It's actually quite nice if you want to show some kind of disturbance event, like forest disturbance, like changes in grasslands, or like fire events and so on. So it's up to you how you would like to use it. Now let's move towards something more advanced in QGIS, and it will be about accessing Copernicus data space ecosystem layers directly in QGIS environment. Raise your hands who don't know what is Copernicus data space ecosystem and never used it and never looked at the layers in it and so on. Are there people like this? Okay, I see only a couple of people. Okay, so what is Copernicus data space ecosystem? So we discussed during our very first webinar last Friday that European Commission has, and together with European Space Agency, has this European Union space program, and as a part of it, there is a constellation of satellites which is called Sentinels, and the program by itself is called Copernicus. And those satellites provide different types of Earth observation data, and this data is free of charge. Everyone can access it. It provides repetitive measurements globally since 2015 or 2017 or some later years, depending on the satellite. And apart from this, there are some Copernicus contributing missions, which are more high resolution satellites, which belong to other space agencies around the world or private companies. And they have different types of sensors installed of them. And this data together, that Sentinel data and those contributing missions, and also a lot of field measurements, put together, can provide us huge amount of different indicators and information about state of different habitats, ecosystems, and so on. So Copernicus data space ecosystem has six main topics, and those six thematic areas are called oh my god, I can't find it. Just a second. Called Copernicus services. So there is something related to marine information, climate change information, disasters information, and so on. So here in the data tab, you can read more about different Copernicus services. For example, Copernicus Land Monitoring Service, which will provide information such as information about forest cover, grasslands, soil moisture, different changes and disturbances in those types of land cover. Then there would be also a Copernicus Emergency Management Service and Atmosphere Monitoring Service. And in general, there are six of them. Let's take a look closer at Copernicus Land Monitoring Service. And for example, Korean land cover is a part of Copernicus Land Monitoring Service. Here you will find a lot of very boring, potentially, and lots of letters information about different layers available in this specific service of Copernicus. But there is also a viewer, which will be much so if you Google Copernicus Land Monitoring Service, and there will be a specific website for this one, and you will be able to find here the portfolio of different layers available, data viewer just to visualize those layers online, and a lot of other information. I see here a question regarding, is core inland cover created centralized or done by member states? To be honest, I don't know. I'm not sure about this, but I think that it's centralized. But honestly don't know the correct answer for this question. So here you will find the portfolio of different groups of layers, like land cover, priority areas, biogeophysical variables, and so on, like land satellite mosaics. So we can read about all those layers here. So, for example, there would be like croplands and tree-covered forests and grasslands and water and wetness and so on. So we can take a look at some of those and see what kind of data sets are offered to us here. Those Copernicus high-resolution layers are quite cool because they are relatively precise. They are 10 meters per pixel, meaning it has quite a high spatial resolution. And those data sets are available. For example, for grassland layer, it's like every year starting from 2015. So it's basically a map of all grasslands around Europe. This information was derived from Earth observation data together with not only Sentinel-2 or 1, but also some contributing missions together with a lot of field data and a lot of validation. We got those maps and they are updated annually. Apart from this, there would be also a map, for example, of mowing events and plowing events, and those layers also updated annually. Also, there are a lot of layers related to forests and tree cover density, dominant leaf type, and forest type, and all this information is also updated on an annual basis. And now the most important question: we are supposed to work with this, right? Because those are nice layers, can be very interesting, very usable. We can, on this website, we can view it in a data viewer, for example, just to take a look at it. But how we can actually calculate something? How we can derive any statistics from all those layers? Like, it's nice to look at them, right? But where is the statistics basically? So what you can do, so apart from visualizing it here, those layers are also available as a WMS service for those who has experience working with GIS. It's basically some kind of link if we copy it, here will be written that this URL has been successfully copied to clipboard, which we can just add to GIS software, and it will be also visualized on our screen, and we just can take a look at it. But something better than just WMS service, I would like to show you today. It's a special plugin for QGIS, which is called Copernicus Connect. And to take a look at it, we of course need to open QGIS. So if you have QGIS on your computer, please open it. If you don't have QGIS on your computer, I can send you a link very quickly. Yeah, so link is already in the chat, and if you don't, you need to download this QGIS, like download the long-term release. It's LTR. There is abbreviation next to the name, and depending on of course, on the system you're using, Windows or Mac OS, you need to select. Just give me a second to open QGIS. If you have any questions so far, please ask. No questions. Okay, so this is QGIS. It's open source, free of charge GIS software, which has a lot of capabilities. It's for those who never used it before. What you can do here, you can visualize different geographic geospatial information, vector layers, raster layers, satellite imagery. You can perform different operations to satellite imagery, put together several layers, make maps, collect field data, visualize it here, and so on. To add different functionality to the software, different companies, organizations, or enthusiasts, they create something which is called plugin, because of course there is some built-in functionality, but apart from this, there are all those plugins which help people to access or do some things which are not initially here. So in September last year was released a plugin which is called Copernicus Connect. And for you to access it, you need to go to plugins, manage and install plugins. And here find something which is called Copernicus Connect. Here it is. And for those who doesn't have it installed, you just need to click install plugin and it will be installed very quickly. And after installation being finished, you will find this icon here. And by clicking on it, you will launch this Copernicus Connect plugin. And I clicked on it and I don't see it. Just a second. Here it is. So this is the interface of this plugin and what it basically does. So via this plugin, you can access all information from Copernicus data space ecosystem, from all those 6 domains, like land monitoring, marine, atmosphere, and so on. And by to find those layers, you just need to enter here like keywords from the name of that layer, define the geographic area you want it to be visualized or downloaded for, and then visualize it as a WMS service, so like an online layer which you just can visualize, but you can't really calculate anything using it, or you can download information from your selected area of interest as an image and then perform different calculations on it. I will take a look. There's something happening in the chat. Okay. Question was asked and then it was replied to. Great. Okay. So before you accessing information via this plugin, you need to create an account. It's even if you already have a Copernicus account, it won't work. You should create another type of account. And I already logged in, but you for the very first time when you try to use it, there will be something like this, and here will be written that to register for a free account with this WEKEO and gain access to its service, you need to go to the registration page. So you just click this registration page, and you need to fill very quickly this information about yourself. Sign up and it will be done. So then you just need to use this username and password you created for yourself, and you will be able to access it. For those who are following, I will give you just 1 minute. Michael, could you specify what kind of dependency issue you're having with this plugin? Well, I would recommend to just relaunch QGIS, because even though it's a fantastic, very nice and functional, just because it's slightly unstable sometimes, just relaunching may help. Yes. Okay. So from Gisco, it's like I think you know what is Gisco. It's just like GIS for the Commission website. I downloaded a shape file with all the different NUT units for the EU. And from them, I selected one really small one, the Liberec region of Czech Republic, just to show you how to really do something for your area of interest. So let's imagine you are interested in some kind of grassland statistics, and we saw at the Copernicus website that there are different layers available for grasslands, and it can be mowing, plowing, grasslands in general, just maps of grasslands and grassland change, and so on. So we would like to take a look at it and to be able actually calculate something, right? So what we need to do here in filter, we just need to enter grassland and click update. And we will see a list of different layers which actually correspond to this keyword. So there will be, CLMS, it's Copernicus Land Monitoring Service. HRL is high resolution layer because it's 10 meters per pixel. It's quite precise. Grasslands for year 2017, for example, resolution 10 meters. And then you will see that grassland layer for all those years starting from 2017. And then there also will be like this grassland moving dates, for example, or also like herbaceous cover and plowing events and plowing indicator and so on. So what we want to do, we want, for example, to download some information for this nuts on grasslands. We want to compare, for example, 2022 and 2023, right? You may ask why layers from 2024 are still not available, whereas the layer for 2025. The thing is that creating those layers, it's a quite complicated from the computation point of view, because lots of data sources, a lot of information is used to calculate that layer for the whole of EU. So it really takes some time to process this information to provide such a precise data set to its final user. So for now, what we can do, we can compare 2022 and 2023. So let's try to download some information for this specific area of interest and then do different manipulations with it. Here, what should be mentioned that if you want to download this information will be given to you in the so-called tiles. Tiles are basically, because this layer is so big, it's for the whole of Europe, right? And to download it all, it can be like a lot of gigabytes to download, you know? So if you want for it to be more convenient to use, this data set is split into tiles. So one tile is basically like a one square of information, like one image. And sometimes for you to cover your area of interest, you need 1, 2, 3, 4, 5, 20 of those tiles. But it's not a problem. You just need to define for which area you want to download this information. And to do so, using this plugin, you need to select show query parameters. And here we will define that we will use this outline, this polygon, which again is some kind of nuts in the Czech Republic. I called it statistical unit for we want to derive it for this statistical unit. And here we need to select product type. So there it will be grassland change, then mowing dates, mowing events, herbaceous cover, plow indicator, and so on. And I want it to be grassland. And this layer is available in different resolutions, but of course we would prefer the best available, so 10 meters per pixel. And then we need just choose year and let it be 2023, and then we'll download separately 2022 just to compare. And then we just click in request data. And here we will see notifications that there are 4 results found and they are 20 megabytes. 4 results means that for this area of interest to be completely covered, there are 4 tiles. And then you just need to click download, or you can choose folder first and then download it, and it will be downloaded really quickly. I pre-downloaded it because, unfortunately, internet connection sometimes can be unstable, so I didn't want to risk, and I just want to show you this information. So here it is. This grassland map for 2023. As you see, there are 4 images, right? So 4 different tiles. They're all square shaped. And for this area of interest to be covered, we needed 4 of them. So what this layer is showing to us? First of all, there is some kind of palette of colors. So 0 is not grassland, 1 is grassland. Again, this layer was derived from Earth observation data. And the very first and quite convenient thing that, of course, you can mosaic. So for those who been using GIS before, you know that you can mosaic rasters in QGIS, and you can clip out the area of interest using this red boundary layer from this mosaic. And then you can just do the regional statistics, run the regional statistic tool on it. But even from the beginning, you downloaded those 4 tiles to QGIS, immediately you can just open one of those images and click here open raster attribute table, and you will see immediately here already some statistics calculated automatically from this layer, how many square kilometers of grassland and non-grassland is present here, the percentage, how many percents of this area is grassland and non-grassland. And then you can do the same for 2022. And just like this, even without running any complicated analysis, you already see some statistics. So you see specifically how many square kilometers or hectares of grasslands are present inside this area already. Apart from this, in the same way, using this Copernicus Connect plugin, you can download other types of data sets, for example, this mowing events or plowing indicator, which I already did. It was done in the same exact way which I showed you before when downloading this grassland layer. And here it is, basically. So we can already see some changes, even visually. So we can calculate some statistics from these layers. We can just visually see it already. We can use it for making maps, reports, and so on. Also interesting data set is this grassland mowing events. So this is the map. Of course, we need to understand what it's actually showing us and see some statistics. And what we can do, we can just open attributes of one layer. And here already, even before running any geospatial analysis, we can see what each of the colors means. So there are non-moving areas, grassland areas which have been mowed once, twice, 3 times, 4 times, and so on. The area in square kilometers for those grasslands and the percentage of the area covered by this scene and so on. So already quite precious information. And the same with this plowing indicator. The same with this plowing indicator. Just by, even before performing any complex steps, you can just open raster attribute table and see here quite precise information which is already calculated, and you already can use these numbers for something. So far, are there any questions? I don't see any. Okay. Next thing which I would like to show you is another plugin which is called Sentinel Hub. Again, for those who are slightly familiar already with all those things, before there was a Sentinel Hub, now it was like Copernicus browser, free of charge, easy to use for visualizations and so on. But now the thing is called Copernicus browser, but plugin is still Sentinel Hub. So we can try to install this Sentinel Hub plugin. Again, by going to manage and install plugins. And we just put here Sentinel Hub. Here it is. You just need to click install. It will be done very quickly. And you will see an icon. You will see an icon here using which you can launch it. So both of those plugins, they are just for us to be able to access directly Earth observation data without downloading terabytes and gigabytes of it on your computer, because one satellite image, just one satellite image which covers like 30 on 30 kilometers, for example, so it's quite small area, it can be several gigabytes. And for you to compare different, for example, types of land cover between years for the whole country, it can be 100 gigabytes, 150 gigabytes, and so on. And it's just quite complicated to analyze something like using this amount of data on your computer. This is why it's quite convenient to use those plugins to access this information remotely without downloading it on your computer, be able to visualize some things, calculate something which are already there, and so on. So this is the Sentinel Hub plugin, and to be able to access it, you need to create a client, authorization client for it. So after clicking on that blue link, you will see this page, and here in the beginning you just need to click account settings, and you here on the side you will see this OAuth clients, and you need to create a new one. Just clicking create, you're giving it a name. Let's call it test, and just click create. After this, don't close the page, because you need to copy this client ID and client secret and paste it into the plugin inside the QGIS to be able to access different capabilities and layers provided by this plugin. So copy it, paste it into the plugin. And after this, you will be able to log in, at least log in to this plugin. But then after logging in, you need to create a configuration. So how to create a configuration? We are going back to this Copernicus dashboard. We already created this client. So we are going to this configuration utility, and we are creating new configuration. You can give it a name, and then there will be a list of different templates, and from the general group, you just need to select full WMS template. So this configuration utility will provide you all different visualizations, using different sentinels like this moisture index and the vegetation health index and different band combinations and everything you can do in Copernicus browser, but in Copernicus browser you're seeing it online, right? It's not really helpful if you want to put some maps together inside QGIS, right, to be used for further work or some reports and so on. So you just create this full WMS template, give it a name, and click create configuration. Now, after this configuration was created, you see list of all different visualizations you can create for your area of interest inside the QGIS using this plugin. What is a nice thing about this plugin? It's that you can create your own visualization inside this configuration. And it's done in a completely same way, like we were doing it in Copernicus browser by just copying and pasting some custom scripts, or you can create your own custom script if you know that there is something you would like to monitor or you would like to see and map using Earth observation data. So there can be someone in your department or in your organization who knows how to do those things, and they can help you to put a script together. So let's imagine we want to create a new layer, like a new type of visualization. For example, the one we did before, this forest disturbance one. So we're just creating new layer and we are calling it like forest disturbance. Classification. Forest disturbance classification. The source of imagery. Let's choose again. So there is like level 1C and level 2A for Sentinel-2, and we know that level 2A is analysis ready data, meaning that it was cleaned from all the errors, artifacts, it was auto-rectified, and so on. So we can click select here source of information Sentinel to level 2A. And here, click the edit icon, and we will see here custom script editor. So what we need to do, we can just go back to this first disturbance classification or use any other custom script or visualization you would like. You can just copy it. Copy it, paste it here. Choose set custom script, click save, and it's done. So now we have this configuration created and how we can access it. So we are going back to QGIS. We are logging in again. And here we'll see the message on the top that login successful. And now in our configuration, in our list of configurations, you will see this, the one you just created. And now you can choose how you would like it to be visualized using WMS or WMTS service. WMTS can be just slightly faster, especially if you have bad internet connection. But otherwise, it doesn't make any difference. And you can select which one you would like to use. So again, you see a list of all these different visualizations designed for different purposes, different indices, chlorophyll, moisture, water index, some geology indices, and here it is, our forest disturbance classification one. Apart from this, you need to decide for which date you want it to be visualized. So we want to use exact date, for example, and we want it to be, again, we can set a threshold for cloud cover percentage, and we are selecting some kind of date. Let it be 22nd of, no, let's better, because in winter months, autumn months, there are a lot of clouds. So for seeing forest disturbance, it's better to select something within summer months or like early September. So let's imagine July. Let it be July the 1st. And we are just clicking create. Now let's see how it look like. You can see here that it's downloading this visualization. Now we need just wait. I hope you have better internet connections than mine, but trust me, in the end, there will be a visualization. So far, are there any questions? Even if they're not related to those plugins and access to Earth observation data. Here it is, this visualization. In the same way, you can visualize any other layers, indices, visualizations, and so on. I don't see any questions. And because there was no questions today, we finished quite earlier than we planned, because it's everything from my side what I wanted to show to you. Okay. Yeah. Is there a Python package you can recommend to access the API? There is something which is called OpenEO. So it's like a combined, it's like a Python package, which basically combines four backends. It's Copernicus data space ecosystem, it's Google Earth Engine, and other two backends. I think it's I'm not sure about R, to be honest. If there is a R package for OpenEO, but yeah, I will try to find the link. Just a second. For OpenEO. What is nice that again it's for free. They give you some credits for free every month, and if you're representing an organization which is not commercial one, so it's some kind of state organization or state agency, and you are doing some processing first observation data using OpenEO, and you run out of credits, you can just contact them and they will give you more processing credits for free, which is quite cool. Okay. If you feel that you would like to understand how to do different things in QGIS, but you've never been using QGIS or any GIS before, contact us via our CEF website, and we will be happy to plan and organize another more more detailed, let's say, training for those who want to start doing some things with Earth observation data in GIS. If there will be requests like this, we will definitely design a course on it. So please contact us.
Indeed, if you want to contact us, the email of our project is on the screen at the moment. It's at evenflow.eu. And also, I just want to thank Natalia for the very interesting sessions. For the next session next week, we will continue with the advanced EO applications with the presentation from different use cases of like applications from the agricultural statistics, from ecosystem accounting and wetland inventories. all of this information will be once again communicated with you via email. So stay tuned and see you next week.
Thank you everyone for joining today. Have a nice weekend.
Bye bye.
Thank
Bye.
you. Bye bye.